Hello everyone and welcome to our new section which is called Trie. Till now we have learned different types of trees such as binary tree, binary search tree, AVL tree and binary heap. Now in this section we will learn another type of tree which is called Trie. In this section you will get a deep knowledge about Trie data structure, which includes creation of Trie, common operations such as insert, deletion and search on Trie. In the first lecture, let's see what's a Trie and why we need it. So let's get started. A Trie is a tree-based data structure that organizes information in a hierarchy. While most of other structures are designed to manipulate generic data, Trie is often used with strings. It is used for storing words in a way which enables fast lookups. Since Trie stores characters at each node, it's very efficient for prefix matching in English language. So let's look at the properties of Trie. The first property is it's typically used to store or search strings in a space and time efficient way. And the second property is any node in the Trie can store non-repetitive multiple characters. And the third property, every node stores a link of next character of the string. And finally, every node keeps tracks of end of string. Now let's look at these properties one by one. Basically, when we work with strings, our main goal is to make the search operation as efficient as possible. Then the ideal data structure is Trie data structure. Now a typical Trie looks like this. So if you look at this Trie structure over here, we see that each node has multiple children. It can have 2 or 3 or any number of children over here. And we also see that in each of the node, we can store 1 or 2 or 3 or any number of characters. So here in the first node, we see that we have 2 characters. So here we have 3 characters. Here we have 1 character. So this is the second property of Trie, in which we say that any node can store non-repetitive multiple characters. Now here you need to be careful that here we say non-repetitive characters. Now you might be interested why non-repetitive characters. So we will explain this in a while. Just bear with me. Also, we see from this tree that every node stores the reference to the next node. So if you look at this tree over here, we can see that, for example, root node has 2 references, to this node and to this node. Then this node has reference to its child and others also have reference to their child as well. So every node stores the link of next character of the string. And finally, the last property says that every node keeps a track of end of string. Now if you look at this tree over here, we see that at the end of string we have empty nodes over here in which we sign them with black dots over here. So these dots over here mentions that this is the end of string. So this is Boolean value, we are setting it true or false. So if the parent of these nodes is the end of string, then we are setting these nodes end of string property to true. So in this case you see that all of these nodes are set to true. So this means that these are the separate strings over here. Now if you look at this Trie structure carefully, we can easily see that we have stored multiple strings in this Trie over here, which are AIR, so AIR, AIT, AIT. So every time you see that we have end of string over here, then BAR, it starts from here, BAR, then BIL, then BIL, and then BM. So you see that here also we have BM end of string over here. Now we have 5 strings stored in this Trie over here, and let's see how we store these strings over here on a very high level. Now let's say if we want to store AIR, all we have to do is we have to create a blank node, then store A in it. Then we create one more node and store I to it, and this will be the child of this A over here. Now for R, we will create another node and we will store R over here. And after storing R, we need to mention that this is end of string. So we will create a blank node and we will set the end of string property of this blank node to true. So this will show that this is the string over here and this is the end of string over here. Now if you want to insert AIT to this Trie over here, one more time we have to create nodes for each character over here. But here you need to take into account that first we are checking if the node is exist in this Trie or not. So in this case we see that A is exist over here, then we will continue to the next node. So in the next node we see that we are looking for I and we see that I exists over here. So we will continue to the next node. So in the next node we have R over here, but we need T. So we will insert T over here. Then we will link this T to the new node, which will be the blank node, and the end of string property of this node will be set to true. So this will show that AIT is another string. Now let's continue to add another string over here. So another string will be BAR. So as always, the first step is we will take first character over here and compare it with root node. So in this case, we see that we need B, but here we have A. So we will insert B over here. Then we will continue to the next character, and for the next character we will create new node and assign this character, which is A, to it. Then similarly we will create a new node for R and assign R to over here. Then after finishing this, we know that this is a complete string, so we need to set the end of string property to true. So we will create new node over here and set the property of this new node to end of string. So whenever you see that the property of end of string is set to true, it means that the parent node of this node is end of string over here. Now let's continue to the next word. Now the next word is bill. So we need to insert this BIL string to this trie over here. So as always, the first thing that we are going to do, we will compare first character with the root. So we see that we have B over here, so we will not insert B as a node over here, so because we have it over here. Then we will continue to the next node. So in the next node we see that we have A, but we are looking for I, so we will insert I over here. Then we will continue to the next node. So in the next node we have R, but R is linked with A, so we need to create a node which is linked to with I. So we will create a new node which is linked with I, and we will insert L over here. Now after inserting, we know that this is end of string, so we need to create a new node and assign end of string to it. So finally, the last string is BM. So we need to insert BM over here. So as always, we see that B exists over here, so we will not insert B. Then we will continue for M, and we see that in the next node we don't have M. So we will insert M over here. Then after inserting M, we know that this is end of string, so we need to create an empty node and set it end of string property to true. So this will denote that this is end of string. Now here we have explained just a simple case of trie data structure, but there are more complicated versions of it. So now hopefully everything is clear about what trie is. Now let's see why we need to learn trie data structure. So in the world of computer science, there are many problems that can be solved easily using trie data structure. For instance, the spelling checker or autocomplete of strings feature are done by using trie data structure. Now when you go to the Google and search for any word, you see that Google suggests you when you start to type any letter. You might be interested how Google predicts the next letter. So one way of doing this is using trie. This suggestion comes from the trie data structure. So simply when you type A, whatever the next node is there, we return all of them as a suggestion. In that way, we simply implement a Google autocomplete feature. Now, of course, Google might be using some more advanced technology, but the logic behind it remains the same. Now, finally, one more thing to note over here is the nodes that we are seeing over here are very simplistic. In the actual world, this is how the typical node will look like. So it will have some characters over here and the links to the next node. So it has a property of end of string over here. So as you see, for example, for this node over here, we will have 3 characters over here and we will have 3 links. And at the end, if this is the end of string, we will set the end of string property to true. Now with this, we have completed this lecture. So in this lecture, we have learned what trie data structure is and why we need trie data structure. Now in the next lecture, so let's learn common operations that we can perform on trie data structure. So see you in the next lecture.